Okay, today's lesson is on 7.1, the rational root theorem, which is a way that we can find the zeros of a polynomial if it has rational zeros. So that means all the solutions, or any of the solutions that are whole numbers or integers or fractions, we can find all of those zeros. If there are any zeros that are imaginary or irrational, like square root of 5 or square root of 2, those are irrational numbers. This method won't work for finding those kinds of zeros, but it will work for finding rational zeros. So rational numbers include integers like 2, -2, 5, -7. Those are all rational. Those are integers, so they're rational. And then it also includes fractions like 1/2 and 2/3 and numbers like that. So rational, in the word rational is the word ratio. And so any number that can be written as a ratio or a fraction, any number that can be written as a fraction is a rational number. So that's why the square root of 2 is not a rational number, because you can't write it as a ratio of two integers. Okay? The number pi is irrational. So those are some examples of irrational numbers. We can't find those kinds of roots, but we can find roots that look like this. Okay? So what the rational root theorem says is that if there are any rational zeros or rational roots, they will be of this form, m over n, where it says m is a factor of the constant term. So if I had a polynomial like, let's say, 5x cubed minus 7x squared plus 3x minus 8, the constant term is the one at the end with no variable. So n is going to come from that number at the end. It's going to be one of the factors, in this case, one of the factors of 8. Okay? And so, and then it says n, that's our numerator, or sorry, our denominator in the bottom. N is a factor of the leading coefficient of the polynomial. The leading coefficient in this case is 5, so that means n would have to be a factor of 5. And so our first task is to write down all the possible rational zeros that we should consider. So go ahead and copy down example 1, and we'll work through this one together. Okay, so we said that our numerator needs to be a factor of 6. So in our numerator, we could have numbers like 1, so positive and negative 1 go into 6, positive and negative 2 go into 6. What else?
3.
Positive and negative 3, and positive and negative 6. Those are all the factors of 6. And then n has to be a factor of the leading coefficient. So our denominator has to be a factor of 2. So what are factors of 2?
Also for -1.
Plus and minus 1, plus and minus 2. Okay? So now we need to list all the possible fractions that we can make with these numbers. So we can get, if I do 1 over 1, so that's plus and minus 1. 1 divided by 1 is 1. I can do 1 divided by 2, so plus and minus 1/2. So I'm done with the 1 in front. Now I'm going to go to the next one. If I take the 2, 2 divided by 1 is 2, so plus and minus 2. And then 2 divided by 2 is 1, and we already have 1 listed, so we don't need to list it again. So I'm done with the 2 now. Now I go on to 3. Plus and minus 3, plus and minus 3 over 2. Okay, so now I'm done with 3. And then with 6, 6 divided by 1 is positive and negative 6. 6 divided by 2 is 3, but we already have 3 listed. So this is our complete list. These are, if this polynomial has rational roots, they have to be any 3 of these numbers, because it's a third degree polynomial. It could have up to 3 real roots, and so we should keep testing these out until we find all 3. Okay? And so let's just start with our first one. We're going to use synthetic division to test these. And we're going to kind of abbreviate the process for for synthetic division, we're not going to write the whole table out, so we're just going to write up at the top 2, 1, negative 13, 6, and then we're going to test. Let's start with positive 1 and negative 1 and positive 1/2, and we'll keep going until we find at least one of the zeros. Okay? And so using synthetic division, I'm not going to write all the steps. We're trying to do it all in one row. And so when I do synthetic division, I would bring the 2 down, I would multiply, and then add. So when I multiply 1 times 2, I get 2. Add it to the next one, and I get 3. Okay, so if it helps you, this is what we're doing. This is the long way that we did it before. We had 2, 1, negative 13, 6. This is how we did it before. We did like this, right? So now the only thing is we're only writing the bottom row. So when we did 1 times 2, we got 2. We added those, we got 3. So we're just writing these answers here in this column. So then we multiply again, we get 3. Add it to negative 13, and we get negative 10. So we're doing this step. We get 3. Add, we get negative 10. Okay? And then 1 times negative 10 is negative 10 plus 6. Negative 4. So that's this step. This times this is negative 10. Add, and you get negative 4. So since we didn't get 0, that means this one didn't work. Okay? So we tried 1. It didn't work. Okay? So let's try negative 1. When we do negative 1, we bring down the 2, multiply, and add. So negative 2 plus 1, negative 1. Multiply, you get 1. Add, you get negative 12. Multiply, you get 12. Add, and you get 18. So again, that one didn't work. Okay? Everyone go ahead and try 1/2. See if you can fill in that row on your own. Okay, Noah, what did you get for that row?
I got
2, 2, negative 12, 0. That's correct. Okay? Since we got a 0 here, that means we found a factor that divides unevenly. So we know that x equals 1/2 is a root. And what would a factor look like that has x equals 1/2 as an answer? Any ideas? We could write it like this, x minus 1/2, but we don't usually have factors that have fractions in them. Can anyone think of an equivalent fraction that has the same solution? Okay, we'll leave that then. We'll come back to it in a few minutes since no one can think of it right now. It'll come up. Okay, so the nice thing about doing the synthetic division is that this last answer that we got tells us when we divide by x minus 1/2, this is the polynomial that we would get, 2x squared plus 2x minus 12. So we know now that our original polynomial, 2x cubed plus x squared minus 13x plus 6, is equal to x minus 1/2 times 2x squared plus 2x minus 12. Okay? What do you notice about this second factor? Okay.
Reduced by 1/2.
We can divide. What can we factor out?
2.
2. So if we factor out a 2, then we're left with x squared plus x minus 6. Now this 2 is very convenient because look at what happens when I multiply it here. Now I get a normal looking factor, 2x minus 1, and then x squared plus x minus 6. Now I could keep going through my list, but now that I have a quadratic here, I can try just factoring that directly. so I don't have to go back to my list of rational roots. And once you get to a quadratic, we should be able to factor the rest of it or use the quadratic formula to help if you are unable to factor it. So this one we should be able to factor pretty easily. What are two numbers that I can multiply to get -6 that add up to 1?
3 and -2.
So x plus 3, x minus 2. Just to check, we get x squared minus 2x plus 3x, and that matches the 1x in the middle. And then 3 times -2 gives us -6. So that is the correct factorization. So our polynomial then is f of x equals 2x minus 1, x plus 3, x minus 2, and the zeros are x equals 1/2, x equals -3, and x equals 2. Okay, so that all that together is our answer. And notice that all three of those zeros, they were on our original list. So if we kept going through that list, maybe if we went through the list in a different order, we might have come up with 2 first, because we tried 1/2. Some people like to avoid the fractions and do all the integers first. So if we would have done plus and minus 1, those didn't work. Okay. Then if we would have gone to plus and minus 2, we would have found that 2 worked, because 2 is one of our roots. And so if we would have avoided the fraction and gone straight to x equals 2, we would have found a 0 there as well. So the order doesn't really matter. Pick whichever ones you think are easiest. And once you get, if you start with a cubic, once you find one of the zeros or one of the factors, then you have a quadratic equation, or you have a quadratic function like we had here, and you can usually factor those by hand without having to go back to your list again. Okay? So that's the general process. We'll do another one together here. Go ahead and copy down problem 2. And after you copy the problem down, just start off by making a list of what you think all the possible rational zeros would include. Okay, just like we made a list for example 1, make a list of all the fractions that we need to test. Okay, so for our rational roots of the form m over n, m has to be a factor of 20. So factors of 20, plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 5, plus and minus 10, and plus and minus 20. Did I miss any? So a lot of factors of 20. But fortunately, n is a factor of the leading coefficient, and so n has to be a factor of 1, and there's only one factor for our denominator. So that makes it a little bit easier since we have such a long list in the top. So then when you divide all those by 1, you just get plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 5, plus and minus 10, plus and minus 20. So now we have our list of possible rational roots. And so we're going to test them by putting the coefficients of our polynomial on the top, and we'll put the number we're testing here. So this is going to be 1, 2, -19, -20. So I'm going to start with my first one, 1. Multiply, or bring down the 1, multiply and add 3. Multiply and add -16. Multiply and add -36. That's not 0, so that one didn't work. Now we try -1. Bring down the 1, multiply, and add it to the 2. That's 1. Multiply, you get -1. Add it to -19, that's -20. Multiply, you get 20. Add to -20, you get 0. So after only 2 tries, we found another rational 0. So x equals -1. That corresponds to the factor x minus 1. And what's the remaining factor? That comes from right here, remember? That corresponds to x squared plus x minus 20. So x squared plus x minus 20. So that's our function is with one factor, looks like that. Can we factor it more?
Yes.
So x minus 1, and then how do we factor x squared plus x minus 20?
Well, I have a question. Wouldn't it be x plus 1 since it's a negative?
You're right. It is x plus 1. So x minus x equals negative 1 is the 0, and x plus 1 is the factor because we're doing x minus a, and a is negative 1, so that is plus 1. You're correct. So x plus 1, and then who can factor the remaining part, Eric?
X plus 5 times x minus 4.
Does everyone agree with that? Okay, so we have it in fully factored form, and our zeros are x equals negative 1, x equals negative 5, and x equals positive 4. So we have our factored polynomial, and we have our 3 rational zeros. Any questions? Okay, go ahead and copy this one down. Those that are watching the video, press pause and then try to work out the entire problem, and then press play when you're ready to see the solution. Okay, so since m has to be a factor of 3, our numerator is going to have plus and minus 1, plus and minus 3. Our denominator has to be a factor of 2, so n could be positive or negative 1, positive or negative 2. And so that gives us the fractions plus and minus 1, plus and minus 1/2, plus and minus 3, plus and minus 3/2. So those are all the possible rational roots that we need to consider. And so our polynomial, since there's a 0x squared term, a 0x squared term missing right here, we need to put that when we do the synthetic division, we need to have 2, negative 1, 0, negative 6, 3 as our numbers across the top. And so if I start with 1, bring down the 2, multiply, you get 2, add 1. Multiply 1, add 1. Multiply 1, add negative 5. Multiply negative 5, add negative 2. So that one didn't work. So now we'll try negative 1. Bring down the 2. Multiply negative 2, add negative 3. Multiply 3, add 3. Multiply negative 3, add negative 9. Multiply 9, add 12. So that one didn't work either. So our next one I'll try is 1/2. And so if I bring down the 2, multiply, I get 1. Add to negative 1, and I get 0. Multiply, I get 0. Add to 0, I get 0. Multiply, I get 0. Add to negative 6, I get negative 6. And 1/2 times negative 6 is negative 3. Add that to 3, and we get 0. So we just found a factor, x equals 1/2, and the factor is x minus 1/2. Now look at the remaining factor. Normally we would have to keep going. This is going to be 2x cubed minus 6 from these numbers here. Okay, now normally we would have to go back to our list again and try those on this, but we can see that 2x cubed minus 6 has a factor of 2, so we can first pull that out. And so if we pull out that factor, we're left with x cubed minus 3, and that is 2x minus 1. This factor becomes 2x minus 1 when you distribute the 2, times x cubed minus 3. Now, x cubed minus 3 is not a sum of cubes, and it's not a difference of cubes. I can solve that. I can set that equal to 0. So if I say x cubed minus 3 equals 0, then x cubed equals 3. X would be the cube root of 3, which is an irrational number. So I can't factor that anymore. I know that the remaining factors are irrational, so I'm really done. I have, what I have is, we should have 4 roots, four possible roots, but we're only getting 1 rational root. Okay? And so the factored polynomial is f of x equals 2x minus 1 times x cubed minus 3, and we only have 1 rational root. Or 1 rational 0, roots and zeros. Okay, so that's all we get for that one. And we'll go ahead and stop there. And that should give you a good start on today's assignment.